When installing an additional service in a commercial building, it is necessary to rebond the gas and water lines within that addition. The National Electrical Code, specifically Section 250.104b in the 2020 edition, addresses this requirement directly. This section pertains to systems installed on other structures, stating that systems installed on additional structures served by a single service shall be bonded to the service equipment grounding conductor or the grounded conductor that supplies the additional structure. The purpose of this bonding is to create an electrically safe environment by ensuring that all metallic systems within the building are at the same electrical potential. This reduces the risk of electric shock and minimizes the possibility of damage to equipment due to stray currents. Bonding, in this context, refers to the intentional connection of metallic parts to form an electrically conductive path that is capable of safely carrying any fault current likely to be imposed on it. This path must have sufficiently low impedance to facilitate the operation of overcurrent devices, such as circuit breakers or fuses, in the event of a ground fault. The specific requirements for bonding gas and water lines are detailed within Section 250.104b of the NEC. The gas piping system and interior metal water piping system must be bonded to an effective ground fault current path. This bonding connection must be made to one of the following locations: firstly, the service equipment enclosure; secondly, the grounded conductor at the service; thirdly, the grounding electrode conductor, if of sufficient size; fourthly, one or more grounding electrodes used to meet the requirements of NEC sections 250.52 and 250.53. The size of the bonding jumper for gas and water piping must be determined in accordance with NEC Table 250.122, using the size of the ungrounded conductors that supply the service. It is important to note that the bonding connection must be accessible and made in a manner that ensures a permanent and reliable connection. The bonding jumper must be protected from physical damage and securely fastened to the piping system. The location of the bonding connection is also critical. It should be made as close as practicable to the point where the gas and water piping enter the building. This minimizes the potential for differences in electrical potential between the piping system and the surrounding earth. In cases where the gas and water piping are not continuous throughout the building, additional bonding connections may be required to ensure that all sections of the piping system are effectively bonded. For example, if the gas piping system is interrupted by an insulating fitting, a bonding jumper must be installed to bridge the gap and maintain electrical continuity. The NEC also addresses the bonding of other metallic systems within the building, such as metal building frames, metal siding, and metal roofing. These systems must be bonded to the building's grounding system to prevent them from becoming energized in the event of a fault. In addition to the requirements of the NEC, local codes and regulations may also impose additional requirements for bonding gas and water lines. It is important to consult with the local authorities to ensure that the installation complies with all applicable codes and regulations. Proper bonding of gas and water lines is an essential safety measure that protects building occupants from electric shock and minimizes the risk of damage to equipment. It is important to follow the requirements of the NEC and local codes to ensure that the installation is performed correctly. Here are some additional considerations for bonding gas and water lines. Firstly, use listed bonding clamps and connectors that are specifically designed for the type of piping material being bonded. Secondly, ensure that the bonding jumper is of sufficient size to carry the maximum fault current that is likely to be imposed on it. Thirdly, protect the bonding jumper from physical damage and corrosion. Fourthly, inspect the bonding connections regularly to ensure that they are tight and free from corrosion. Fifthly, document the bonding connections and keep a record of the installation. Ignoring these bonding requirements can lead to several potential hazards. Firstly, electric shock. If gas or water pipes are not properly bonded, they can become energized during a fault. Touching an energized pipe can result in a dangerous electric shock. Secondly, fire hazard. Electrical faults can generate heat, and if gas pipes are not properly bonded, this heat can ignite flammable materials nearby, leading to a fire. Thirdly, equipment damage. Stray electrical currents can damage sensitive electronic equipment connected to the gas or water lines. Fourthly, code violations. Failure to comply with NEC and local codes can result in fines and penalties. Fifthly, liability. If someone is injured or property is damaged due to improper bonding, the responsible party may be held liable. To ensure that the gas and water lines are properly bonded, it is recommended to hire a qualified electrician. An electrician will have the knowledge and experience to perform the installation correctly and in accordance with all applicable codes and regulations. The electrician will also be able to inspect the existing grounding system and make any necessary upgrades to ensure that it is adequate to protect the building. In summary, bonding gas and water lines in a commercial building addition is a critical safety measure that must be performed in accordance with the NEC and local codes. Proper bonding protects building occupants from electric shock, minimizes the risk of fire and equipment damage, and ensures code compliance. Always hire a qualified electrician to perform the installation. Furthermore, consider the specific context of your commercial building addition. For instance, firstly, is the addition a separate building or an extension of the existing structure? If it's a separate building, the NEC requirements for grounding and bonding become even more stringent, necessitating a separate grounding electrode system. Secondly, what type of gas and water piping is being used? Different materials, such as copper, steel, or plastic, require different bonding methods and connectors. Ensure compatibility and adherence to manufacturer's instructions. Thirdly, are there any sensitive electronic devices connected to the gas or water lines? If so, consider installing surge protection devices to further protect these devices from stray electrical currents. Fourthly, is there any existing corrosion on the gas or water pipes? If so, address the corrosion before bonding to ensure a reliable and long-lasting connection. Fifthly, what is the soil condition around the building? Soil conductivity can affect the effectiveness of the grounding system. In areas with poor soil conductivity, additional grounding electrodes may be required. Remember to consult with a qualified electrical engineer or inspector to ensure that your installation meets all applicable codes and standards. They can provide valuable guidance and ensure that your building is electrically safe. In addition to the physical bonding of the gas and water lines, consider the importance of proper documentation. Keep a record of all bonding connections, including the location, size of the bonding jumpers, and the type of connectors used. This documentation can be helpful for future maintenance and inspections. It is also important to educate building occupants about the importance of not tampering with the bonding connections. Remind them that these connections are essential for safety and should not be removed or altered. Finally, remember that electrical codes and standards are constantly evolving. Stay up to date with the latest changes to the NEC and local codes to ensure that your installation remains compliant and safe. Consider attending continuing education courses or subscribing to industry publications to stay informed. Bonding gas and water lines is not just a one-time task. It is an ongoing responsibility. Regularly inspect the bonding connections to ensure that they are still in good condition and properly connected. Address any issues promptly to maintain the safety and integrity of the electrical system. Also, be aware of the potential for changes in the building's electrical system that could affect the bonding requirements. For example, if the service size is increased or new equipment is added, the bonding system may need to be upgraded to accommodate the increased fault current. Always consult with a qualified electrician or electrical engineer before making any changes to the electrical system. To further enhance the safety and reliability of the electrical system, consider implementing a comprehensive grounding and bonding plan. This plan should outline the specific grounding and bonding requirements for the building, including the location of grounding electrodes, the size of bonding jumpers, and the inspection and maintenance procedures. The plan should be reviewed and updated regularly to reflect any changes to the building's electrical system or the applicable codes and standards. Remember that proper grounding and bonding is a team effort. It requires the cooperation of electricians, engineers, inspectors, and building owners. By working together, we can ensure that buildings are electrically safe and that occupants are protected from the hazards of electric shock and fire.